Have you ever really stopped to think about how things, well, how they move? It seems pretty simple, right? But the world is constantly in action, from a car driving down the street to a swing at the park. In this explainer, we're going to break down the secret language of motion that's happening all around us, every single day. All right, let's kick things off with a little puzzle to get our brains working. Think about a bicycle. It's moving forward, right? In a straight line. But its wheels, they're spinning in perfect circles. So, how is that even possible? How can one object be moving in a straight line and in a circle at the exact same time? Let's figure it out.
To crack this little mystery, we need to gather a few clues. And once we understand the most basic, fundamental types of motion, the solution to our bicycle puzzle is going to snap right into place.
Okay, let's get into our first two clues, moving in a straight line and moving in a circle. First things first. First up is something scientists call rectilinear motion. I know, it sounds a little complicated, but trust me, it's incredibly simple. It just means anything moving in a straight line. That's it. From point A to point B, no curves, just one straight path.
And you see this everywhere. Think about students marching in a parade. They move in a perfect, disciplined, straight line. Or even something as simple as an orange falling from a tree. Gravity pulls it straight down. Both of those are perfect examples of rectilinear motion.
Okay, so obviously not everything moves in a straight line, and that brings us to our second clue, circular motion. This one is exactly what it sounds like. It's just an object moving along a circular path over and over again around some central point. Just picture a merry-go-round at the fair. All the horses are tracing a perfect circle. Or think about whirling something on a string above your head. Its path carves a circle through the air. Yep, that's circular motion in action. Okay, so we've got straight lines and circles, but there's one more piece to our puzzle, a type of motion that has its own kind of rhythm. This is our final clue.
So far, we've focused on the path of an object. Is it straight or is it a circle? But there's another really important element, timing. What do we call it when a motion repeats itself over and over again in a perfectly predictable rhythm?
Well, that brings us to periodic motion. Put simply, it's any movement that repeats itself in a fixed amount of time. You can think of it as motion that has a predictable beat or a really steady rhythm. Now, this is the key. Periodic isn't a single type of path. It's a whole category of motion. So our merry-go-round that's in circular motion, since it repeats its path every few seconds, it's also periodic. The same thing goes for what's called oscillatory motion, which is just a great term for anything that moves back and forth. The best example of this is a kid on a swing. That back and forth arc just repeats over and over again. That movement is oscillatory, and because it has that steady rhythm, it's also periodic. Okay, we've got all our clues: rectilinear, circular, and periodic motion. It's time to head back to our bicycle and finally solve this puzzle. So remember our big question, how can a bicycle move in a straight line and in circles at the exact same time? With our new tools, the answer is actually pretty elegant. So here's the solution. The frame of the bike, the part you actually sit on, is moving straight ahead. That's rectilinear motion. Meanwhile, the pedals and the wheels are rotating. That's circular motion. And what about a single point on the tire? Well, it's doing both at once. It's moving forward with the bike and it's spinning in a circle. This just shows that different parts of the very same object can have different types of motion, all at the same time. This idea of combined motion isn't just for bicycles. It's happening everywhere once you know how to look for it. Let's check out one more quick example to see what I mean. Okay, so let's follow Pahaley on her walk. She starts off walking on a street road, which we know is rectilinear motion. But she doesn't just walk to the end. She turns around and comes all the way back. And she repeats this whole trip 5 times. Because she keeps repeating that same path, her motion is also periodic. So her simple walk is actually a combination of both rectilinear and periodic motion. It's that simple.
So, as we've seen, motion isn't just one simple thing. It's layered, it's combined, and it is absolutely everywhere. Which brings us to you.
We've given you the tools, the secret language to decode all the motion that's happening around you. So now it's your turn to be the observer. Here's a challenge for you. For the next minute, just look around you. How many different types of motion can you spot? Is that ceiling fan exhibiting circular motion? Is the car outside in rectilinear motion? What about the ticking hand on a clock? Is that periodic? Once you start looking for it, you'll realize you can never unsee it. The whole world is in action.